Okay, so we have here our fourth problem. So given triangle XRT and triangle MRT, and also another given, okay, we have here line segment TR is the perpendicular bisector of line segment XM. So we want to prove, okay, we want to prove that both of these triangles, triangle XRT and triangle MRT, are congruent. Okay, so triangle XRT, okay, XRT and MRT are congruent. So how do we do that? Okay, so again, we have here our format for our two-column proof, and from here, we can write our statements and our proof. Okay, and again, so the first thing that we do is we write our given. So our first given is TR is the perpendicular bisector of XM. And again, the reason or the proof for that is simply given. Okay, it's a given information. Okay, and number two, okay, so let's just try to clean this up. So guys, what do you think is the second statement? Okay, so we can try to write that here. Okay, so for our second statement, we can say that since TR is the perpendicular bisector of XM, what does a perpendicular bisector do? It's a bisector, so that means it's simply, what we call that, it creates two congruent segments. Okay, so if we have your XM, it's going to cut XM in half. Okay, and we have here R, the point R as the midpoint. Okay, it's the midpoint, and therefore we have here the two congruent segments XR and XM are congruent. Okay, so how did we say that? Because that's the definition of a perpendicular bisector. Okay, so this is how we write our proofs. Again, you can use your laptop, you can use your electronic gadget or your smartphone, and also you can use your paper and pencil if you're used to that. But since we're in a technological age, I advise you, or I encourage you guys to use your laptop in writing your proofs or for this theorem. Okay, and then we have here the third one. Okay, since we know that TR is a perpendicular bisector of XM, we've established that, and we've already established that XR and RM are congruent. We can say that TR, okay, line segment TR is congruent to line segment TR as well. And again, what's the proof for that? Okay, so we write that as the reflexive property of congruence. Okay, so that's simple. Okay, so that's free. TR is congruent to TR, and that's simply the reflexive property of congruence. Okay, and then what more can we say? So it's also given here, guys. If you notice, we have here right angles, the symbol for a right angle, kind of like a square. Okay, so if they're right angles, okay, so we have here angle TRX and angle TRM. Okay, so they're right angles, and what are right angles? They measure 90 degrees, and therefore if both of those angles measure 90 degrees from both of those triangles, we can say that both of those angles are congruent. Okay, because they're both 90 degrees. So for, okay, we can say that angle TRX and angle TRM are congruent. Okay, so they're congruent because that's the definition. Okay, that's the definition of a right angle. Or we can also say that right angles are congruent. Okay, so we can write two proofs for that. Okay, angle TRX and angle TRM are congruent, or that's a definition of a right angle, or right angles are congruent. And therefore, we have proven, okay, so we can state the last statement here. Okay, we can write the last statement here. We can now say, or we can now confidently conclude that triangles XRT and MRT are congruent, okay, are congruent based on the SAS, or the side angle side triangle congruence postulate. Okay, so how did it become the SAS triangle congruence postulate? Because we've already stated that, okay, we've already stated that TR, okay, so TR is congruent to itself based on the reflexive property of equality, and XR and RM are congruent. Okay, because that's the perpendicular bisector. And this angle right here, the included angles are congruent. And therefore, based on the SAS triangle congruence postulate, we can say that triangles XRT and MRT are congruent. Okay, so for our enrichment activity, we want to try to prove whether the two triangles inside a quadrilateral are congruent. So this is leading to the congruence of different types of quadrilaterals, which is the main chunk of our lesson for our geometry subject for this second quarter. Okay, so we have here proof 5. So we're given here parallelogram quad, and QA is the diagonal of the parallelogram. So we want to prove, okay, when we drew the diagonal here, we formed two triangles. Okay, so we have your triangle QUA and triangle ADQ. Okay, so we have those two triangles right here. We want to prove that these two triangles are congruent. Okay, so in order to do that, we need to refresh our knowledge about the properties of quadrilaterals. Okay, so if we try to remember the properties of quadrilaterals, specifically parallelograms, we can easily prove that these two triangles are congruent. Okay, so for our first statement, again and always, we write our first statement as a given. Okay, so that we can make our proofs easier. So the first one, we have QA. Okay, QA is the diagonal of parallelogram. Parallelogram quad. Okay, and from there, we can simply state that's a given. Okay, so let's just arrange that. And guys, what do you think could be the second statement? Okay, so the second statement here, guys, can be, okay, we can say that QA, okay, QA is congruent to QA, okay, or to itself based from the reflexive property of congruence. Okay, so you can write that here. Okay, let's just write that neatly. QA is congruent to QA based from the reflexive property of congruence. So what do you think, guys, is the third statement? So we can write here our third statement. Okay, so if you're trying to review the properties of parallelogram, guys, so a parallelogram is a quadrilateral with two congruent sides, two pairs of congruent sides. Okay, so if it has two pairs of congruent sides, then we can say that these parallel sides UA and QD are congruent. Okay, so if you can try to recall, and we're also going to prove that property, okay, in our future lessons. But for now, let's take that property, okay, and take advantage of that. So UA and QD are congruent, and QU and AD are congruent. Okay, so let's write that here. Okay, so wait a minute, let's just delete that, and let's write here number 3. Okay, UA and QD are congruent. Okay. Okay, so and number 4. Okay, we can write 4. What do you call this? QU. Okay, QU and AD are congruent. Okay, so what's the reason for that? So that's one of the properties of a parallelogram. So we can simply write that as a definition of a parallelogram. But if you want to go to specifics, or you want to make it more specific, so we can write there the two pairs of opposite sides, okay, opposite sides of a parallelogram are congruent. Okay, so if you want to go specific on that, but the definition of a parallelogram, so that's simply it. You can simply write that as the reason or the proof. But if you really want to go specific on that, so here we have here this reason. Definition of a parallelogram, or the two pairs of opposite sides of a parallelogram are congruent. Okay, so let's write that neatly. Okay, so we've already established that QA is congruent to itself, UA is congruent to QD, and UQ is congruent to AD. And therefore, we can now prove that these two triangles are congruent based from the SSS triangle congruence postulate. Because, okay, so let's just write that first. Triangles QUA and ADQ are congruent. So both of these triangles are congruent based from the side, or the SSS triangle congruence postulate. Okay, so why are they congruent? Okay, so if we try to analyze here our figure, we've established that QA again is congruent to itself, and UA is congruent to QD, and UQ is congruent to AD. So those are three sides that are congruent to the corresponding sides of the other triangle, 3 corresponding sides that are congruent to another triangle's corresponding sides. And since QA is a side that that both of those triangles share, so we can say that based from SSS triangle congruence postulate that triangles QUA and ADQ are congruent, and therefore we've proven that both of the triangles here are congruent. So these are some of the proofs, okay, some of the proofs that we're going to have here in our subject, geometry. Okay, so this is kind of like an introduction, and we're going to dive deeper into them in our next modules and our next lessons. Okay, so thank you for listening.